nearly an hour done already, guys. We're absolutely flying through this. Yeah, brilliant. This one? No. Yeah. I think.
Good morning, guys. I just want to start with a question. Have you wanted to control the world outside you with your thoughts? And I mean physically control. Like say move a wheelchair or turn the next slide using your thoughts. And if you do, then that's what my project was on. I'm exaggerating a little bit, but I'll explain more. I worked on brain-computer interfaces. So brain-computer interface is a technology that uses that will let you control the outside world using thought alone. How does this work? It works, so there's several ways of making it work. I used a technology called EEG. So when your neurons inside your brain fire, they produce these electrical signals, and you can measure it on your scalp. So these EEG headsets, they detect that signals, and once you detect it, you send it wirelessly over to a computer, and then the computer processes it and decodes where your thought came from, and then sends commands to devices like, say, a wheelchair or the presentation to go to the next slides, anything. The possibilities are immense. So that's the brain-computer interface, how it works. But there's a problem. The problem is your thought signals. I would call it the thought signals. It's not the actual technical term. It's just not signals coming from the neurons, but when you blink your eyes or when your muscle moves, they also produce electrical signals. This is what you call noise. Okay, I was supposed to have some more things there, but so these noise signals, they mix in with your thought signals and they make your data messy. And that's a problem because, say for example, I wanted my wheelchair to move forward by thinking, and if I blinked my eyes at the same time, the wheelchair might move backwards or it can go unstable, it can get really messy. So these noise or artifacts causes big danger. And my project was to remove these artifacts so you can have better systems. And traditionally people have done it like visually by looking at data and rejecting relevant segments, but I implemented automatic noise removal algorithms. So it's just automatically removing it so that you can get better data. And so this is my signals from my head. So what you're looking at is, not on the one on the right, but on the left. What you're looking at is, on the left side is me blinking my eyes, at the same time thinking about moving my left hand. And on the right, it's what my brain would look like after I remove that noise. So if you look on the left, there's that huge yellow blob, and that corresponds to my eye blinks. And on the right, it's that removed. And as you can see, the computer will like the right picture more. It will be better able to decode that. And so before I send the signal to the computer, it's better if I remove the noise. So the whole point is remove the noise so that the computer can be better able to decode what your thought was. And that should hopefully make better brain-computer interface systems. So that's it in a nutshell, and if you have any questions, please do come and talk to me.